Hi, we're going to take a quick look back to scientific notation like you learned back in secondary 1 and then move it forward to what we have to do in secondary 3. So scientific notation, as you should recall, is a way of writing large numbers or small numbers in a different way. So when we have this, it's always going to have only one digit before the decimal, followed by one or more digits, and it's multiplied by some power of 10. The exponent on the 10 tells us the magnitude, the size of that number. So here we have 3.254 times 10 to the 3. So really, that number, 3.254, is going to be multiplied by 1,000. So the 3 tells us the decimal should be moved 3 places to the right. That's the way we change. So let's take a quick look at how this works. Scientific to standard means if it's a big exponent, in other words, positive exponent, you're going to move the decimal to the right. So just like before, 10 to the 3 means you move the decimal 3 places to the right, giving you a number 1,500 for 1.5. It becomes 1,000 times bigger. If you're looking at small numbers, well, the first thing you're going to notice is that the exponent is going to be negative. So when you move the decimal, you're going to have to move it to the left to show that the number is actually small. So 2.63 times 10 to the negative 3 means times 1,000th. Okay, so the equivalent of dividing by 1,000. So we take that decimal, we slide it 3 places to the left so that the standard form is 0.00263. And notice we put that extra 0 in the front to just signify that, yeah, there's a decimal that we don't want to ignore. To do the reverse, standard to scientific, well, basically, if it's a big number, we're going to have a positive exponent on the 10. And so you'll move the decimal to the left to sort of like balance it out. So 8,500 is a big number. So we take that decimal, we move it 3 places to the left, but because the main part, the coefficient of the number has become smaller, the 10 to the 3 balances it out to say, oh yeah, this is really times 1,000. If it's a small number, then this time we're going to have a negative power of 10 because we move the decimal to the right. We make the number look bigger, but that exponent is going to counterbalance the fact that it's really bigger than it is. So that 0.789 becomes 7.89. You move it 1 place to the right, you multiply it by 10 to the negative 1. Now, the reason we put this format together is really so we can do some calculations. Add, subtract, multiply, divide. Multiply and divide is actually easier. So all you're going to do is you're going to multiply the coefficients, that is those numbers in the front of the powers of 10, and then you add the exponents on the 10. So in this case, 1.5 times 3 is 4.5, and 10 to the 3 times 10 to the 5, you just add the exponents to give you 10 to the 8. Division, same kind of thinking as multiplication, except that now we're going to divide those coefficients, the numbers in front, and then we're going to subtract the exponents on 10. So 6 divided by 2 is equal to 3 times 10. 2 minus 4 is negative 2 for our exponent. Now, addition and subtraction, as we're going to see, is going to be the one that has a little more challenge to it because we have to make the exponents match, which means we have to change all of the numbers of scientific notation to have the same exponent. So for example, 6.5, I can rewrite it as 10 to the 3. The exponent goes up by 1, so the coefficient goes down by 1 decimal place. The 2.0 times 10 to the 3 remains the same. And then in that third one, 10 to the 4 is a large number, but we're going to make the 10 to the 3 to make it smaller. Therefore, the 3 has to become 30. Oh, whoops. And then at the end of it all, you're going to just take 32.65. You add up those 3 coefficients together, and then you have 10 to the 3 as your magnitude. And don't forget that at the end, you have to remember to change the number back into scientific notation by putting only 1 digit before the decimal. Hopefully this helps, and when we're going through some problems later on, just remember you always have to write that final answer in scientific notation. So back to this, 632 times 10 to the 2 is considered a large number, but we got to rate it with one number before the decimal, gets smaller to become 6.32, and so the exponent on the 10, the magnitude, must become larger. Here's a small number, 0.0754 is going to be moved, the decimal is going to move to the right, making the number bigger, and so the exponent is going to have to go down by 2 to keep the balance. After a little bit of practice, hopefully you'll remember it all. All right? And remember, the digits in the coefficient are very, very important. Okay? They're called significant digits.